Okay, we have here today another interesting integral. We've got the integral of 2 times cosine of 7/2 x times cosine of 3/2 x dx. Okay, now to get started with this, it's kind of interesting there's a 2 here, right? Because we could just bring this outside of the integral. But really the thing I want to focus on here is with these cosines, it's just that we have a different angle here. And we could do this really quick using the different angle formula. But what I wanted to do is actually derive those formulas from the angle sum and angle difference formulas. Okay, now we have our angle sum and angle difference formulas for sine and cosine here on the board. So assuming we already know what we have here on the board already, from this we can pretty easily derive the angle difference formulas for cosine, sine, and sine cosine. And one other thing I wanted to mention before we get started deriving this is we really only need this one and this one, because if you think of this, for sine A minus B, like you could write this as sine A plus minus B, and then just use the first formula, and you could do the same thing with cosine. And that's why the only difference in these two formulas is just the sign, the minus sign here. Notice plus becomes minus, minus becomes plus here. Okay, so to get started with this, what I'm going to do first is we're going to just take these first two equations and add them together, noticing that when we do that, the sine B cosine and the minus sine B cosine, those terms are going to cancel. And then we're going to be left with down here, we're going to have just two of these, 2 sine A cos B. And then the left side, we're just adding these together. But then if I just multiply on both sides by 1/2 and multiply by 1/2 over here, we'll notice the 2 times 1/2, this is going to cancel. And this is actually going to give me my first formula I want. So when we have sine times cosine with different angles A and B, we can just express that as sine of the sum of the angles plus sine of the difference of the angles times 1/2. So like I said, pretty easy. You're just adding the two equations together. And we're going to do the exact same thing with cosine now. When we do this, these terms on the right are going to cancel because of the plus and minus. And so we're just left with 2 of these, 2 times cosine cos B. And then we'll have this on the left side. And then again, I'll multiply by 1/2 on the left side and 1/2 on the right side, but the 1/2 is going to cancel with the 2. So I'm just going to get rid of that. And that's going to give us our formula for cosine times cosine with different angles A and B. And just notice that's going to work fine for our problem, right? We could just label 7/2 x A and 3/2 x B. But one thing I want to do before we get back to the integral is we've got a different angle formula for cosine, we got a different angle formula for sine times cosine, but where's our formula for sine A times sine B? Well, for this thing here, all I need to do is kind of go back into my angle addition formulas and find it. So we actually have this right here for cosine. Now what was happening was when we added these two together, these canceled out and we lost this term. So all I need to do now is just subtract them. So if I actually subtract, if I take cosine A minus B and subtract cosine A plus B, then we're going to cancel out this other term. So let's just see. This is going to be cosine A minus B, and then I'll subtract cosine A plus B. And then when we do that, again, these terms are going to cancel here. We end up getting 2 copies of this. So we'll have 2 times sine A sine B. I can divide by 2, multiply by 1/2. This is going to cancel here. This question mark is going to go away. I can erase this business. And then we get our different angle formula for sine A sine B. But I should probably move it a little bit to the left, right? But again, we don't need this formula and this formula for this problem. We really just need this cosine A times cosine B formula. Okay, so now back to our integral, and using what we found on the previous board, we have our formula. And we said that our A value up here is going to be 7/2 x, and our B value is going to be 3/2 x. And one other thing we're going to use, we just have this 2 in front. Typically we show the formula in this form, but we could just put it back and multiply by 2 on both sides. So now we can use this as our formula for our integral. So I'll go ahead and rewrite this now using this. So we're going to have the sum of the angles. So 7/2 x plus 3/2 x is going to be 10/2 x, which is the same as 5x. And then let's just add this other term, and we just want the difference of the two angles. So 7/2 x minus 3/2 x is 4/2 x, or just 2x dx. But now at this point, it's really easy to integrate. We'll just integrate and we'll find this is going to be sine 5x, but we need to divide by 5. So this will be sine 5x over 5, and this is going to become sine 2x over 2 plus c. And this is fine, but alternatively, you know what I can do, just because we have this sine 2x, we can use the double angle formula on this. And if you prefer, we could write it as sine 5x over 5 plus 2 sine x cos x over 2, just using our double angle formula for sine. But then the 2's are going to cancel, and I can add a plus c. I can clean this up really quick, and that's it. Okay, good problem. I got this one from my quiz, different angle integrals. If you want to check that out, I'll provide a link in the description. Thanks everyone for watching. Have a great day.